I see students struggle with the idea of inverses and onto and one-to-one all the time, and I just felt like it would be important for me to make a video to talk about inverses, what they do, what their definition is, and why it's so important if it's onto and one-to-one. So here, let's just say that if I have an f of x, it exists. It is an output. Okay, and x is guaranteed to exist. That's guaranteed by the definition of a function. And technically, in the course in abstract algebra, we actually call this the image of f. And you see that I've drawn my y equals x squared. I'm going to claim that f is my function. It goes from the reals to the reals, and it is defined by f of x equaling x squared. Okay, and I'm telling you that if I have, and can we just be able to say that this is an a to a b? We might want to be able to talk about that. And a little bit more abstract, which reals and which reals. So if I say A, I'm talking about the domain. And if I say B, I'm talking about the codomain. Now, if you're really familiar with this function, and I'd like you to be, you know that this one it's not onto. This example is not onto. Not onto. And why is it not onto? It's not onto because squaring always leads to a positive. And so this codomain is too big. All right. So B is made up of the reals. We've got the reals that are positive and we have the reals that are negative, and nothing maps over there in the negatives. Okay. In this example, because you can't get this. You can't it's always positive. So B is too big. That's okay. I'm not worried about that. I'm going to go over onto and one-to-one, and I feel like right now, immediately, I've just explained to you what onto means. Now, what about the inverse then? What am I going to do with an inverse? So if I say that f of x is an output and x is guaranteed to exist, then the inverse image of f is such that x is guaranteed to be in that inverse image. And this is some kind of a subset, right? This is some kind of a subset that is going to be decided upon. I want to mention in this case, I could say R, or I could say R plus, or I could even say, something smaller than that. And specifically, if this is an output in that subset of the codomain. Now, what do you want it to be? Well, to be really illustrative, I am going to pick it to just be two numbers, okay? Literally just two numbers, 1 and -1. And that straddles right here, okay? And so I'm saying that x is guaranteed to be, if I say that f of x is inside of my subset, and I'm going to call it k, k equals 1 and -1. Then f inverse is the inverse of that subset k. And so, all right, so now we have an example where I am going to define that inverse with this k. Now, to draw a better picture of it, here's my A, and here is my B, and here is my K, and here is my inverse of K. Now, we take stuff from A to B by F, and we take things from F inverse to K, like that. And just in case it confuses you that the arrow is going in this direction, because we focus on the fact that K existed, okay, and K is this 1 and K is this -1, and it's a very small piece of the reals. How come I don't draw the arrow in this direction is because the inverse image of F is all the inputs that map to F, F of K. That is specifically the definition of it. And so now I can say that X is in F inverse of K implies that F of X is in K. And I could say it in the other direction as well. And it's literally by the definition of image and inverse image. Okay, and I want to go into this whole idea of one-to-oneness now, and on-to-ness. So let's say that F goes from R to R, and we just discussed the fact that that would not be on-to. Does my inverse have to be on-to? Meaning, if I look at elements that are in K, do I have to map them over here? Are there going to be elements inside of here where -1 goes backwards? And right now, I'm hoping that you pause and think about it. So, is F inverse on-to? Necessarily. And the answer is no. I mean, I already drew the picture. You know that -1 can't be mapped to by a squaring function. So we were over here. We're in the reals where it does get mapped, and here are where the reals do not get mapped. Those are my positives and those are my negatives. And we already knew that -1 does not get mapped. So there is no there's no element here, and I'm going to call it like what, an A sub 1. There does not exist a map to here. Nope, that just is not a thing. You can't draw it. It does not exist. So F of A sub 1 does not equal -1 for any A sub 1 in A, or any A sub 1 in the F inverse of K. Just can't happen. So F is not necessarily on-to. Okay. What else? Let's talk again about, now that we know that this function might not be on-to, it seems, that it's clear that it may or may not be 1-to-1. Right? So 1-to-1 says that the codomain, on-to says that the codomain is actually the range. So in order to make this an illustrative example, in order to even talk about one-to-oneness, we're going to have to restrict F. So where did that go? So you have to start with on-to. So let's have F go from the reals over to the positive reals now. And that means that here is A and here is B. And I am saying that F of A is all of B because F is on-to. All right, so I now know that I can take a 2 and I can map it over here to a 4, and I could take a -2 and I can map it over to that 4, and this definitely is going to take place. It's totally okay. Now, here's the problem though. I've drawn an input and I've sent it to an output, and I've taken this input and I've also sent it to the same output. And if I do that, then what I have is not 1-to-1. So F is not 1-to-1 because f of 2 equals the same thing as f of negative 2, which is 4 equaling 4. And that is not allowed. Okay? Because 2 is not equal to negative 2. We need these two to be equal, to be true. I need a true statement there instead of a false statement there if I want it to be 1 to 1. So how could I change this then so that the function is 1 to 1? Well, it's very easy. I knock out that negative 2, right? I turn that into a plus, and I have positives going to positives, and then I'm happy. But just for a moment, I want to talk about that inverse. So is the inverse of f going to be a function? If f is not, if f is on 2, but not 1 to 1, well, it turns out the answer is no. Okay, it will not be a function. Why not? Because if I take the inverse of 4, I have to take it back to the 2 and the negative 2. And that means I have one input, and that one input leads to 2 outputs. And that means that it is not a function. We covered this in our class very thoroughly, the idea that if you map one input to 2 different outputs, you're going to end up failing the vertical line test. And specifically, if I say that I'm here and I'm at 2, and if I'm here at 4 and I have a height at 2 and I have a height at negative 2, then this fails the vertical line test. It fails it right here and it fails it right there. So the inverse doesn't have to be a function. And that's just something really, really powerful that, that an inverse image, it matters. If we define it to be on 2, we have to decide that it's on 2. If it is 1 to 1, if we decide that it's 1 to 1, things can happen in an inverse that cannot happen in a function. And so the inverse does not have to be a function. And, for that matter, when the inverse is a function, it specifically creates a situation where something is 1 to 1, where the original, a function, will be 1 to 1, and the inverse itself will be a 1 to 1. But I'll leave that for another video in the future.